Seven more people. Should I wait for everyone? Or we can get started. Huh? Get started? All right. Hi, everyone. If you can hear me, clap once. If you can hear me, clap twice. Nice. Cool. You can count. Anyway. My name is Liz, and I am not a stand-up comedian. I am actually the developer content marketing manager at Streamlit / Snowflake. In previous lives, I've been in marketing, I've been a writer, I've been an engineer, I've been a developer advocate, so I've kind of come full circle. Thank you for joining us tonight. How many of you were disappointed that it wasn't pizza? That's funny. Good to know. So thanks for joining us tonight. We have 4 speakers this evening. They're all going to be really awesome, really exciting. There's going to be some cool insights there. So I'm coming over here to get my notes. Let's see, any other housekeeping? Oh yeah, housekeeping. Bathrooms are over there. As you know, food is back there. The exits are here and here. Cool, let me pull up So our first speaker is gonna be Gabriel. And he's gonna be talking about lessons from building a SaaS prototype on Streamlit and scaling it to support 50 concurrent users. So how many of you kind of run into problems like that as you're using Streamlit? You're like, how do I scale? Yeah. So you're going to want to pay attention to this one. So let me tell you about Gabriel. Where are you? There you are, cool. 1 second, my notes are loading. I volunteered to do this last minute and they were like, it's cool, keep it casual, informal. So cool. Gabriel has a rich background in leading teams and implementing scalable AI technologies. He has experience creating distributed services for major broadcasting networks like NPR, graduated studies at MIT CSAIL, has successfully exited 2 startups, one in EdTech, where he created a training and assessment platform that has been integrated into Elsevier's SharePath, which is a premier nursing education platform, and at Doc.ai, which was acquired by ShareCare, where he spearheaded the machine learning platform and solutions teams. So come on up.
Do I need to hold the microphone? Or?
I hope not. Who's our AV person? Hi, does this mic up here work? Oh, check.
Hello? Hello?
There you go. Thank you, Kyle. Yep.
Hello? Okay, I'm gonna hold it. So yeah, thanks for the introductions. Can everybody hear me? Okay, awesome. So I'm here today to talk to you about how we build a SaaS prototype on Streamlit. And I'm not new to Streamlit. I've been using Streamlit for the last 4 years, even before it was acquired by Snowflake. And this was my first exposure to Streamlit. There was this article on Medium. So one day I was looking for a solution I was assigned to build a no-code ML platform for healthcare. I was running out of ideas, and then I ran into this article. I'm like, great, now I have a solution. I'm not gonna build a low-code platform, but I'm gonna build some kind of data app. Back then, we used to call them internally fluency apps that we can share, ML engineers can share their experience with SMEs, nurses, clinical teams, and so forth. And since then, we built labeling apps, different prototypes, recommendation systems, evaluations, and so forth. And then when I started when I left ShareCare, I was looking for something to do, and I met my co-founder, we decided to build like a co-pilots for the creator like economy, like co-pilots for creatives. And then the easiest thing to do to validate the idea is to build something on Streamlit. So we built a feedback platform where people can teach courses and also give feedback on the platform using AI. So this is an example. I'm going to show a demo at the end, or like see how this. So imagine like somebody uploaded an image. This is an image by my co-founder that like she allowed me to use of her painting. She's also an artist, where somebody uploaded an image for an instructor to give feedback. And then the way you communicate with those stuff is like, imagine you're an instructor and you're giving feedback. It's like, okay, I think the hut needs to be darkened. And then you just like communicate with this app using like natural language, and you will have that like hut darkened. So from before and after, and then you can like tweak a little bit the values with that field. If you want to do something else, like warm the sky up, then you will type that in and say annotate the image, and then again you will have the model detecting the skies and then like warming it up, detecting actually the color and warming up the skies. And then if you're not happy with the color, you can have like a just-in-time editor where you can like play with the values. So how did we start? It's like, why Streamlit? Streamlit is really like, I can build an app in a day and then deploy it and test quickly and fail fast, so I can move much quicker. So you start with like, your app on your local machine or a VM, and you're like, okay, what do I need next? Where do I go from here? You find, like the easiest thing is Streamlit Cloud. You deploy it on Streamlit Cloud. You add, which basically adds a container or wrap it inside of a VM inside of the cloud, and then you add like, some DB for state. But then as you continue to develop the app, you discover limitations. So where do you go from here? There's many options. Heroku, Render, Cloud Run, like there's so many options that you can do. So you take that app and you run it on kind of a VM. So like that's like, okay, we decided to run on like an EC2 instance because we want to scale. First of all, let's solve the 1 gigabyte problem of the image. And then you discover very quickly, if you want to scale it, like run some basic load test on an EC2 instance, you discover after 5 users, like the Streamlit app is not going to handle very well. Like you're going to have timeouts, you're going to have like failures, all sorts of things. So immediately like, okay, like you think about, I need to definitely scale it like horizontally. Adding a load balancer, and this is kind of like the common wisdom. And we came up like, like easy, like we're in GitHub. So like using GitHub Copilot, I like suggested like, okay, I'm on AWS. I'm going to deploy it on ECS. That's the easiest thing to do. Like really like no much effort involved. And then you're asking is like, does it scale? Definitely it scales. Like I'm testing here on 10 users and like, well, it seems the app is doing something like that load balancer adding and then like scaling the container horizontally helped me a lot. But if I test on 20 users, then I can start seeing problems. So like, okay, let me look into what's happening and then like, what can I do to remedy those issues? And I'm testing it, I'm looking at it, it's like the app is not loading while I'm running those tests. So common things that, was added like, like a couple of years ago to Streamlit is like caching. Caching is your best friend in Streamlit. Not only caching data, but caching resources. So the first thing you do is like, let's wrap all my like, DB connections with like, with the ST cache resource. And it's gonna solve the problem, but I'm not sure about the models. If I'm gonna wrap the models, like, should I run models on my Streamlit app? That's something we're gonna touch on a little bit later. But definitely, if I have a model, I'm gonna wrap it with a HTCast resource because I don't want my if in Streamlit, it's tornado based, it's running. Every user has his own session. So if you wrap it with cache resource, like the whole users will have like that one cache resource, and you can like define the parameters for it, like how like what's the expiration date and so forth. And then there's other stuff to worry about, like IO operations. So if you're serving, in Streamlit, if you're like having an ST image, then that image is served from that container. So like you wanna decouple that as well. So either you put it on a CDN or you definitely like create like a pre-signed URL. That's the easiest like route to go. And that takes you like a long way. Like you're testing here on 15 users, you're noticing some glitches and like you're not sure what's happening. Like I already did my caching, I already did like, my like CDN and like, offsetting my IO, but something is happening. So like, what do I need to do? What next I need to do? And then like, let me increase my test a little bit more. And like this is like 30 users and I definitely see something happening. And this is, maybe most of you will not hit that, but if you're using extensions, those extensions are also using like, their own IO that is loaded inside like the Streamlit instance. So for example, here we're using Canvas. We had to like copy it over, like fix the code inside to like kind of use CDN and like, caching and so forth. So, but once you do that, like this is like me running on 50 users. This is like running on 50 users on like Streamlit container of like 2 CPUs. And this is just a test, but this is like, okay, great. I'm ready to serve my 40 user class. And I just can scale the containers a little bit more. So in summary, for this lesson is like at the end I scaled with like horizontally my container, and then I'm having a CDN, and then there's other stuff. It's like definitely I need to like put the right like, DB indexes. And one thing that I really found for this ECS is like there's a flag there called stickiness flag. And that flag is like, sometimes I couldn't offset every IO to a CDN. So for example, like some of those extensions needed to have some kind of, it was easier just to keep like that small file served from that Streamlit. So, but if I don't add the stickiness class to the load balancer, because it's kind of a new connection, I'm sometimes getting like a 404 for the images. The image is not found because like the load balancer is like routed in the wrong way. But that's in summary for just serving a Streamlit app with like no AI. So how would you deploy your ML models? So everybody knows, like if I have a Streamlit app, like, and then I deploy it with my ML models, if I have 2 or 3 users, great. But also like, I'm not gonna, if I have a model that requires like, GPU to run in like a kind of short time, is it worth it for me to have now like all my instances? Like definitely not worth it to have like, my horizontal scaling containers to be GPU kind of like include that have GPU on them. So if your model has like an API, great. That's what you want to go. Like if your model is served through an API, like if you're using OpenAI like APIs and so forth, that's amazing. But then if you have custom models, like in our case, running like, when you're developing this stuff, like when you run it, it takes like if you're running SAM and Dino and so forth, it takes 30 seconds on a CPU to get like one inference. So like definitely you need GPU. So you route like basically you wrap it, deploy it in any of the common services like Replicate or AWS SageMaker. So we chose basically to have that stuff. So basically what we're doing here is decoupling. The same thing we decouple the DB, the same thing we decouple the stuff, we decouple the model and kind of like store it on SageMaker for no like better reason, because just we are on AWS, but you can definitely deploy it on Replicate on any of other models. So, but this is the final kind of pilot architecture. We have the ECS kind of like service happening, calling the SageMaker where it needs to, and then you have the DB, and then you have the S3 buckets, which are like kind of acts our CDN. This is what we have. Let me show you how fast, for example, like running this model. So this is one of like my trial class that we created. Oh, by the way, on the platform, we have like around 200 users. This is running, and it's running pretty well. So even though it's Streamlit. So for example, paid users. This is my first experiments running a SaaS on Streamlit. Like my experiments, as I said, like really like on running data apps, and you can say like it's running like pretty quickly, dark and the hot. I can like, play with the values. and change the color of the filter that I would like to use. And you can I'll run another example of warm up the sky and so forth. So you can see once you click on this, then it's gonna warm up the sky, basically find the right mask. And all of this it's really fast. So people can use it feeling it's really instantaneous. And this is our own custom pipeline. We did that, we initially started with our, here in this case, we're using, if you don't wanna use the text, you can also use points to select the points you wanna select, and then it's the same kind of model, we're packaging it into that same endpoint. Yeah, this is, so I talked a lot about scaling, but where is that SaaS that everybody is this is the title of the talk. So yeah, there's payments that we did, user logging that we had our own kind of versions for it using our DB. I know there is so payment we did Stripe. For user logging, we did our own version, but I found recently on some website there is something called ST Paywall that has Google login on. Control plane, right now there's no control plane in Streamlit, but we have it in somewhere else. App monitoring, Sentry is amazing and easy to use because it's all Python. That's all I have. And then I can show you a bit the app itself, so this is the app, it's people can buy courses, the same thing, you have Stripe integration, you can go to your cohort, you can select an image to give feedback on. Once you're here, you can say make the lake bluer. And this is basically running, going to OpenAI, going to the model, selecting that mask, it's all in a second. That's super quick and running on Wi-Fi. You can change the values. You can go and select other, but it's all kind of instantaneous. That's all I have. And then, yeah, that's all I have. Yeah, thank you.
Do we have time for a quick question and answer? Ooh, oh, by the way, sorry I neglected the Zoom folks. Hello out there. Yeah, do you want this?
Thanks. So Sridhar would like to know, not the Snowflake Sridhar, different Sridhar, just in case you're wondering. Sridhar would like to know if you can enable logging during runtime. And you might have some experience with that, but also open to the engineering folks in the room, side-eye.
Enable logging and run.
What's your experience with logs?
Oh yeah, so real-time logs with Streamlit. So you have, if it's on ECS, I can stream it to cloud logs on AWS. But also if I have, that's one thing to do. And then the other stuff, if monitoring for crashes is Sentry. That's.
You might have mentioned it, but is your app, have you actually thought about including generative AI in the process as well? Make a picture of a cat, stuck in a tree, and
yeah. So we played with different models. This is also part of generative AI. We build our own custom pipeline, but definitely we tried going directly edit to image. In stable diffusion, I don't know if you're familiar with instruct pix to pix. That's another stable diffusion with conditioning. We played with all these models, but we're adding more and more features. Right now, this is the features that I have is this is the features that we had for the pilots. We're adding more models, but the goal is adding or changing is different based on the need for the class. The class needed to be it's not adding extra stuff. They wanted to know if their like saturation is correct, if the object is in the right place, if like you know, they need to make the mountain taller. Those type of edits that our users are like requesting, and not just like putting a new object in.
Thank you. Thanks for the talk. So in the worst, when you're having the worst performance, how much was running in process? How much was running outside of the process? How much was running outside the VM?
In the question, so like I have, so as I said, like I have, so the testing was like, you know, like you can scaling the DB and scaling the model are their own thing, no? So, and then we tested, like we test what the test I showed you are tests before like integrating the model, the ML model. But again, it's its own decoupled thing that I have another process to scale it and like different parameters. I was just testing the app itself. Can it even handle loading? Like, you know, people are like clicking, like open feedback, download page, add comment. I was just trying to test like, you know, this type of workload that I created. And that's the test I'm showing here.
Oh, I see.
Yeah.
And I have one more just very quickly. What would you do differently if you were starting again?
I think Streamlit is a great start for anyone to like, you know, put stuff into production. What I would have started differently, like, you know, like looking for not messing, like even spending 2 days on ECS, and we're here in GitHub using Copilot to help me create that ECS like Terraform. I would like avoid that, no? So if there is a service that would do that, but in terms of like, it worked out for us because, you know, the costs for egress usually are the most expensive. So like all of our services are in the same region. And that's why like this, like it also adds to that snappiness of that thing. So.
Anyone else? Cool. How about another round of applause? Or any online? Any online questions? No.
No,
Okay. All right.
Thank
you. There we go. What was I going to say? Oh, I think my favorite part of that was even though it's Streamlit, like maybe that should be the next model. Cool. Oh, that was really awesome. So quick question. How many people here are looking for a job or who, and this relates to the next talk, but how many of you are currently job searching or maybe just finished up a job search? Yeah, it's kind of rough out there, right? So this next talk will actually be really interesting, I think, for you. Next up, we have Samriddho with Godspeed, an alternative navigation platform for safer pedestrian travel in the Bay Area. There's also some stuff about job searching. He was telling me all about it. It sounds really cool. So quick little thing about Samriddho. He's a UC Berkeley graduate in design and HCI, is an ex-entrepreneur and technologist with experience in various sectors, from health tech to Gen AI. His experience includes co-founding Doomed in 2021 to bridge the information gap in medical procurement with AI in India, catering to over 10,000 or 100,000 plus users during the pandemic. His work lies at the intersection of data, community, and design, where he has built further projects like Godspeed, which we're about to hear about, which aims to address the wicked problems that plague you and I. I want to hear more about that. Currently, he wears the hat of a conversational AI designer at Oracle, working on enterprise AI efforts for scale. So if you want to come on up.
Okay. So my presentation will be half as technical as Gabriel's presentation was, but I'm sure that I'll be trying to solve some real problems out there. And before that, you guys might be wondering, like, who's this guy? Thanks, Liz, for the introduction. A little bit of context about me. My name is Samriddho. I also go by Sam. I've been an entrepreneur in the past. My present defines me as a designer right now. And if I'm not doing both of them, you can find me performing magic at the streets of San Francisco. So a little bit context with respect to how my journey started. I started off with an undergrad in architecture where I co-founded two companies predominantly in the clean tech and medical logistics domain before coming to Berkeley for my grad school. And currently I'm serving as a conversational AI designer at Oracle. Today, my talk is predominantly going to be about two stories of very different flavor. The first being my grad thesis at Berkeley that was called Godspeed. But what is Godspeed? It's basically an alternative navigation system for safer pedestrian travel. Most navigation systems in today's world optimizes for distance so that you reach your destination the fastest. But Godspeed optimized for distance and safety in order for you to rediscover the city with safer routes. But how exactly did we do this, or how did we achieve this? We had a motley of safety data that was fed into a custom-made algorithm that we called PISR in order to build interactive maps for you to navigate safely. Now, if we had to simplify this, there were majorly 3 swim lanes with respect to the safety data. Predominantly, we had a rating platform where users could come and subjectively rate places with respect to how safe they have felt there, along with emails from UCPD, which gave us a definitive quantitative score with respect to the crime occurrence in that location, and streetlight data, because we know that streetlight has a direct correlation with your perception of safety. Now, all these 3 sources of data were analyzed using a large language model in order to get a safety score. Now, this safety score was mapped all over Berkeley in order to get an idea of how the safety paradigm looks like there. Now, with the safety data on one hand, we'll move on to how this data has been fed into this PISR algorithm. What does PISR stand for? PISR stands for Perceived Safety Enhanced Routing Algorithm. Imagine you're traveling from point A to point B. So what PISR does is basically it scans all the nearby nodes and finds out its safety scores and the distances and tries to optimize for the next best node. And it keeps doing this until you reach your destination. Now let's quickly see a short demo with respect to how Godspeed worked. This is how it looked, where the user would come and input their initial address and the destination address and find safe route. It was basically the flow. As a designer, we wanted to make the flow extremely simple because people have been habituated using something like Google Maps, where this flow is very similar. And as you can see out here, it gave us routes, which was not just the shortest route, but also way more safer with respect to the current surroundings. And this was completely built on Streamlit, not just using the traditional features that we have out there, but also the community. I met Adrian last month at a hackathon, and the first thing that came up to my mind is that I learned more about Streamlit, not from YouTube, but from the community. So if anybody out here has contributed to the community, I would really want to thank them because that has really helped me a lot. Thank you so much. Now, this was a little trailer about my experiences in grad school, but what I'm really excited about is the next chapter, is the job market. The job market that is plaguing all of us. Can I see a show of hands again who are looking for jobs or who know folks who are in the job hunt? Exactly. So traditional, we know how it is borderline almost impossible to get jobs with the conventional definition of job hunting right now. Like cold applications, terrible idea. Because by the time you see a particular post on LinkedIn, okay, by the way, this was 5 hours ago and already 100 applicants have applied for it. So what works? Referrals? Isn't it easier to ask out your high school crush than getting a referral randomly on LinkedIn? I think so. So This might be a message that you'll be reaching out to folks on LinkedIn with, but that same dude has been receiving hundreds of these every day. And it becomes extremely overwhelming for folks out there too. So we stumbled upon the concept of informational interviews, where you reach out to a particular person that you really like, whose work you admire, and plant the first seeds of connection and a deep bond is the wrong word. Communication, like you're just paving out the way for you to reach out to them in a future time, and they could help you out in some way or the other. But does conducting informational interviews or just like networking guarantee you a job? No, because not all companies are hiring always. So how do we understand that? Now, this is a loophole. I won't say a loophole, but a hack we found is that one of the greatest key indicators of a company or a startup, to be more particular, to understand whether they're hiring or not, is to observe their capital influx or whether they have raised funds or not. Like this trend is not extensive over every sector, but for tech startups in the Bay Area, this somehow holds true. So we can say that these companies which are raising funds right now, the rate of hiring in these companies have a direct correlation with the funds they have raised. With that, I would like to introduce you to Hustler. What is Hustler? Hustler is something, it's a platform that we created which finds these companies. It's not exactly another job search website because we are not focused on the jobs that are already posted on LinkedIn, but we're trying to predict job openings even before it is posted. So how do we exactly do that? We identify these companies that have raised capital in the last, say, 3 to 4 months. And we list out 4 potential folks you can reach out for informational interviews. But what exactly will you talk to them about? For that, we built Hustler AI. It's a custom agent that takes in your story. Mind it, it's your story, your narrative, not your resume, because we all bluff in our resumes, let's be honest. So once we take in your story, it it takes in the company URL you are interested in, and it researches on its own to craft a tailor-made response matching your skills to that company for you to apply or send these messages at scale on LinkedIn. But I know many of you are thinking that isn't Hustler looks like something that Perplexity, ChatGPT, or Gemini could do? This answer to this is no, because Hustler, the agent that we built, is context induced along with trained over sample messages so that it can accurately map your skill sets to the company or its even projects or the vision goals that it has. Now, with that being said, Hustler, so we tried to build Hustler in such a way that you could do this exact same process. Probably right now you're reaching out to 1 or 2 folks a day. You can reach up to 30 for probably 40 folks a day with Hustler, saving you approximately 6 hours a week. Now, again, without Streamlit, Hustler would not have been possible because iterating fast, because this has been a weekend project, let's be honest, but iterating fast and as Gabriel said, failing fast and building it again, Streamlit has been a great catalyst in order to execute that vision. And just the way without a Streamlit, Hustler wouldn't have been possible. I would like to thank my co-creator Kabir out there, without whom this thing wouldn't have been possible either. So can we have a round of applause for Kabir for a second? Thank you so much. If you're looking for jobs or you know somebody who's looking for jobs, we have released our wait list. And following our soft launch, we have got over 100 people who are willing to try out Hustler. And if you find this promising, I would really request you to go ahead and join the wait list. Thank you so much. I'm ready for questions if anybody has any. Okay, yeah. For sure.
Right, it's gonna be team effort, okay? Can you all pass this up there?
Hello.
Yeah.
Amira here. Yeah, so my question was, in the first project, how did you operationalize safety? When you were defining it.
That's a great question because as an architect, the definition of safety is, or rather urban safety is one of the most vaguest topics that we can deal with in today's world. So our definition of safety was comprised of three things. First, somebody's subjective understanding of safety in that particular place. So we asked folks that take this place, go to this place if you want, and tell me how safe you feel on a Likert scale of 1 to 10. That is one subjective reading we had taken, along with the crime statistics, as I said, that was generated from UCPD. And lastly, streetlight data. So what we essentially have done is we have created a function of 1 subjective parameters and 2 objective parameters in order to create a definition. To answer your question, there is no unified definition of what contributes to safety holistically. Everybody is coming up with their own research. Godspeed was an experiment in order to understand that how can we use the most practical parameters out there to build something like that, if that answers your question. Thank you.
We have another question from Zoom, again from Sridhar. How do you identify fake jobs posted on startup websites?
Exactly. Thank you for that question. That is why we are not, okay, I think I need to go back to that slide. Okay, not good news. Okay, so we are not exactly trying to go for the jobs that are posted out there. We are trying to predict those companies which will come up with new job postings. So anything existing on the internet with respect to product designer or data analyst role posted 5 hours ago, we are not interested. We are interested in something that's going to be coming up in the future. Yep.
This time a question for me. Can you show us a demo?
Sure. Okay. So this is the page where we first explain this thesis that I just explained to all of you, because again, it's a bit of a complex idea that we're trying to execute with these folks. So how to use Hustler? First, you have to select a startup that interests you, that resonates with whatever you have done till date. We have a list of 40 plus startups till now. We haven't officially released it yet. Our waitlist is out. So we are adding on more startups to this list. Once you have selected a startup, like say, I have selected AudioShake. Let me go to AudioShake's website and copy its link. Now, you can go to Hustler AI, the agent that I spoke about. Now, this is a story that I was testing out with. This is actually Kabir's story, I will not lie. And we can put in the website that we want. This is all you need in order to generate the message. And then you click generate, hopefully it works. Okay, not good news at all. Just a second.
So while we're doing some quick debugging, just FYI, we're gonna have some like networking after this. We have 2 more talks. Then we're gonna do some announcements, and then we have networking. And tonight we have some special guests from Streamlit. We have Amanda and Tiago. If you just want to raise your hand really quick, founders of Streamlit. And yeah, so stick around. And then what about other Streamlit people? Streamlit Snowflake? Identify yourselves. So hang out with us afterwards and you can talk to us. You good?
So Anna, this is the message that Hustler AI generates right now, as you can see. I have not even put in my entire story. It's just like a line just to show it works. And so it takes in the URL of the company and tries to take projects from AudioShake's portfolio and the kind of work that AudioShake has done and tries to correlate it with my skill sets in order to generate a message. And this message can be sent out to scale in the form of a LinkedIn email or a message or an email. I hope that answers your question.
This is brilliant. I love it. Is it going to give me the list of potential hiring managers and recruiters that should be sent to? That's my first question. And second, are you thinking about building a intelligent agent that continuously could be doing this so that I don't have to go through all of those sites?
That's a great question. Okay, to answer your question, the first part of the question, this generally what we are doing is to connect with respect to the work. So a hiring manager is not exactly the best person to talk to about, like, for example, a particular project and go in depth with it. Maybe I want to talk to a particular team lead or maybe a tech lead or a designer. So information interviews, the kind of information interviews we conduct, we mostly talk to those folks, and maybe like if the connection works out, if everything works out fine, then it goes to the hiring manager. What we predominantly do is we list out folks mostly from the tech team, the design team, and the hiring managers or the HR team. Primarily, we are starting off with these three groups of folks, and we are going to expand based on how our tests go around. And could you just repeat your second question, if you don't mind?
I don't want to have to go to every single site.
Yeah. Yes. Yes. So the broader vision of Hustler is to be that AI agent that automatically updates you with one notification that I have sent out to folks. These are the 5 folks I have sent it out to. Here's a summary of it. You understand. And the moment these folks reply, so that you can go and talk to them. So definitely that is the broader goal. But this is like a small step to start with. Yeah. Thank you.
Okay, that's it. Cool.
Okay.
Thank you so much.
Thank you so much. Really appreciate your time.
Yeah. Hustler runs on Streamlit is another phrase I never thought I'd hear, but there you go. Also before, so we have 2 more speakers. And before that, I'm going to get a quick selfie with all of us. I have very short arms, so I don't know. So I think, I'm going to do my best, okay? This is not ideal. All right, everyone say Streamlit. There we go. I am not doing a good job. Okay, sorry. The lights also make it really hard. Cool, so our next speaker is going to be Joshua. Hang on one second. And Joshua is going to talk about an early look at multi-page apps and a new Streamlit primitive, fragments. Who's excited for primitives? Ooh, that's always exciting. And a quick bio about Joshua. Oh no, LinkedIn, why did you do that? Okay, there you go. Joshua is a product leader with 13 plus years of experience in building and scaling platforms, developer tools, data engineering, ML ops, and infrastructure solutions. He spent a lot of 2023 working in the open source generative AI space, and he's passionate about solving complex problems and creating positive impact at the intersection of technology, data, people, and culture. Yeah, you ready to go?
Great.
Cool.
Does this one still work, or should I use that one?
Sweet. How's it going, y'all? Thanks so much for being here. So
Yeah, as Liz mentioned, I'm going to just run through a couple of features that we recently launched and some things that are launching soon, and also show y'all one demo that will be the first time that we'll be showing the demo of the feature, as well as some other stuff that we're starting to work on and would love your feedback on. So let's get started. So folks may have seen in the last release, as Liz mentioned, we launched a new primitive called experimental fragments. It's a way that you can basically have a lot more control over the execution model of your app, which can allow your app to run a lot faster. I was talking with a longtime Streamlit user, data scientist this afternoon. I was like, have you tried out Fragment? And he was like, yep, I tried it out. I had an app that was slow and I added Fragment and now my app is a lot faster. And I was like, perfect. That's exactly the feature. You nailed it. So you can do that too if you have apps that are slow because there's a lot of stuff going on in them and you want to run pieces of the app based on what the user is updating. Just update the relevant parts of the code. You can do that very easily with Fragment just by breaking it up into a function and wrapping it. And one other thing that I'm really excited about with Fragment is that it also has the ability to run functions repeatedly. So in the past, if you needed to update your app periodically because you wanted to get the latest stock price, or you were, tailing some logs or some other kind of real-time data that was coming in, you would have to oftentimes just like have a while loop and just have it run constantly, which is very annoying for a bunch of reasons. But with Fragment, you can just say, hey, just run this function every second, or basically whatever interval that you want, and it will do that. So if I start streaming on this, it's doing that now. So it's getting the latest chart. It's just running every second. And if the user does some interaction, that will just go right in. It's a lot easier to manage than before. So that's Fragments. And yeah, as I mentioned with that, you can just use this run every argument. One other feature that we're very excited about that hasn't launched yet, but is coming quite soon. I think it was merged into our develop branch a couple of days ago. Man, there's been a lot of demand in the community for this. I can have a dialogue in my Streamlit app now and control that. So if you ever wanted to, pop up a little form or some other information with ST Dialogue, that is coming very soon. And that similarly basically just allows you to define the dialogue as a function and then call that function to pop up the dialogue. So that is going to be really nice as well. And I think I've got one more kind of coming soon. Like, you may have seen this demo before. It's not the first time that we shared it, but I think we're very excited about it, which is a selections feature. So if you have a chart, and we'll have this for data frames as well a little bit later, and you want to be able to just know like what the user selected. And I think there are some hacky ways to do this in Streamlit today, but it's kind of a pain. You'll be able to just select that and then get just the data that was selected to draw another chart or pass that information back to the user, or really do whatever it is that you want to do with it. And the code for this is also very straightforward. So, basically you've got a very simple plotly chart in this case, and you're just basically adding one argument for a selection. You could also give this a function, and then you're getting back that event data, and you can do whatever you want with it. So that should be pretty straightforward to implement and use in your apps. And that's, again, something that the community's wanted for a long time. So we're very, very excited to deliver it. Okay, that was just the run through of like stuff that we've already shared. You're like, okay, well, show me the new thing because I'm interested to see that. So another thing that we've really been working on and thinking about is multi-page apps for Streamlit. So if you built a multi-page app, you probably are aware of some of the limitations that have been in Streamlit historically. So, your multi-page app is pretty static. You have to define each page as a separate file. You have to name the file, whatever you want the page name to be, which can be pretty annoying, especially if you want to have some emojis or spaces or anything like that. GitHub doesn't really like those, so it's kind of a pain. And then if you want to change the pages based on something that the user has done, there's really not a good way to do that. We introduced a feature called ST Page Link a couple of releases ago that lets you do something like it, but it doesn't work super well in the native navigation. And there's also not a whole lot of options to customize it. So a few weeks ago, we shared kind of a preview about the new multi-page app API that we're working on. And I have a demo of that to show you today. And you can also go check this out and download the preview will file yourself if you want to play around with it today. So we just posted this. I was working on it this afternoon. So now I have this app. One other thing that you might notice is this nice Snowflake logo in the corner here. The Streamlit does not come with the Snowflake logo. I did add that to the app. That's a little joke. But if you want to add your own logo to your app, you'll be able to do that in one line of code. We know that's something that a lot of folks want to do, for their business or something like that. And then when I press this login button, this is all totally API driven now. So now I've launched into the app. I've got the navigation on the side that wasn't there before. This is all, I'll show you the code. It's pretty straightforward. You'll see that in this side nav, oh man, it's chopping it off a little bit. It looks nicer on my screen than it does there because it's a little bit cut off. So I apologize for that. But you'll see that we've got a section header here. So if you want to have sections in your navigation, if you want to use something other than an emoji for your icons, we've got a bunch of material icons that will be available, and that will be quite easy to use. And then once again, this is totally dynamic. So I can, if I click the log out button again, that just goes away, and there's nothing there's no magic or extra plugin or anything that I had to install to make that work. And I've got my, and I've got all the pages of my app. And this also, another nice side effect of this, basically the way that this will work is you can, so historically for a multi-page app, and this will also still work, sort of the main page that you launch just becomes the home page, but it's just a page like anything else. So what we're allowing is that kind of first page that you're running is actually where you're defining the navigation for the entire app, as well as any common code that you want to run basically on every page of the app. So for example, with my login code, historically, if you had a multi-page app in Streamlit, you have to remember to make sure that you run the login code before every page. Otherwise, if you forget, you could have a page that somebody could get to, which you don't really want. So now you only have to define that sort of in that main file, and that will go through and execute, and then basically everything else. So I had this header in the app that you may have noticed was on every page. I'm just defining that in one place, and it's making it to every page. And then it's here. The sidebar content as well. And then basically I'm just defining the pages here as functions. And then we've got this API called st.navigation, where you're just able to basically pass in a dictionary or a list of pages, define the titles right there in line, define the icons in line. You can, reference material icons by string name instead of having to copy it. And then you get back that page element and you can run it. And then a little fun side effect of this API that I'm also very excited about is you can also wrap the entire page in a try catch. If you want some custom exception logic, you want to send it to Sentry or whatever you want to do, it'll be quite a lot easier to do that. So, I also have a page here that's throwing an error. And instead of getting that full stack trace thing that you're used to having to hack around, you can define something custom. So pretty excited about that. And then the last thing that I'll just show briefly, which I just shared yesterday, is a proposal for authentication. So how many folks have tried to build authentication in Streamlit before? And keep your hand up if you've enjoyed adding Streamlit to authentication in your app before. John gave it a maybe. I think everybody else put their hand down. So yeah, so we're starting to think about, and we'll be working soon on a native authentication feature for Streamlit. And I'd love to just share with y'all kind of some of our thinking about it. And please, this is pinned to the GitHub issues on the repo. So please come and talk to me during the networking section if you have feedback, but also, would love feedback there directly. And basically, we're thinking about kind of two things here. So first, just having some better building blocks for people to kind of build their own authentication. We know a lot of folks are using a reverse proxy, or they have something that they're doing today, but maybe it's not quite as easy to use as we'd like. So things like reading headers, managing cookies, doing redirects, stuff like that. We want to make it easier for you to use, because we know a lot of those things are possible, but they're kind of a pain today. And then we're also looking at actually building an out-of-the-box native integration that focuses on OAuth and OpenID Connect. We think those are two of the most modern kind of authentication standards that will be, pretty standardized to work for a ton of providers. And, for a lot of the use cases that folks have in mind, whether that's using AWS Cognito or something that's inside of your own cluster, or just, hey, I want to add a Google login to my app and know who the user is, that it should work pretty well for both of those. So our goal, which this is a very rough sketch, I don't know if the final version is going to look like it yet, but we're just trying to get feedback again, is that you could go into, your secrets or some configuration file and basically say hey, I want an OIDC, auth in my app. Here's my client ID and client secret. And then we'll just give you kind of some login and logout methods, attach any information about the user in an ST user, and that'll basically be that. Certainly there's other use cases that folks want, maybe I want to use SAML or LDAP, or I have some really special thing. We probably won't have native support for all of that out of the box. Obviously, authentication and security is not our core expertise. We have a great security library, but we don't want to go too far down that road. But we think for a lot of kind of basic use cases, this will get us a long way alongside of those building blocks. So yeah, that's just sharing kind of some of our thinking product work that is in progress, and would love your thoughts and feedback. And I think that's what I've got. So yeah, time for questions.
Well, you hang on to that one.
Okay.
Questions online? Any? Ooh. Oh, yeah, I'll go.
Thank you for all these features. I did not know about this. I need to update a lot of my apps now. The zoom in on charts, is that only for Plotly charts, or is it all any chart that is?
Yeah, when we ship it, we're most likely going to support it for Plotly and Altair, as well as ST Data Frame and ST Data Editor.
Okay, limited. Good.
Is there another one that you want?
I like Bokeh, but you guys are the libraries are mismatched right now.
Cool, good feedback. We'll take that into consideration and figure out if we can do it.
Although I don't like that Bokeh forces you to have the logo right there.
Yeah.
What about the primitive charts?
The primitive charts should also work too. Actually, yeah. Are we adding the argument in the primitive charts? I actually don't know. I hope so. We should. It's Altair, so it should work. Yeah.
Going back to the charts, if it's in a multi-page app and I switch a page and come back, is the zoom going to be?
Oh, that's a good question. I think, let's see. It probably won't immediately work. It will probably have some of the similar limitations of like widget persistence that you have today. There should be a way that if you wanted to save that state and then kind of get back to it, similar to what you do for other widgets today, there probably will be a way to do that. Yeah, but the widget persistence is something that is, yeah, we still have to solve.
And then I was wondering if you could show us this common code across multi-page apps. I wanted to see that common code and just say, hurrah.
Oh, yeah. Oh, thank you. Yeah, you're right. Just a moment.
While you're doing that, just this persistence of going across multi-pages is a real pain.
Yeah. Okay, lost my Wi-Fi, so it's going to take me a second. Here we go.
I will ask while you're looking for, like, do you plan to solve the refresh with login or no? Like when you log in and then you refresh the page, you need to log in again. We had to hack it somehow, but.
Yeah, so I think there's some questions that we have to figure out about having native support for like, I think using a cookie is the obvious way that you would do that, right? So you log in, a cookie stored that's available and it comes back. I think we recognize that it would be really nice if that would work. So we're trying to figure out if we can make that work, and I hope that we are able to. And that would basically be how we would do it, right? So you'd be able to say, hey, add a cookie for this login, have it last for 7 days or whatever, and we'll kind of make that easier for you. Yep. Okay, you were asking about just seeing the common code for the shared app. So yeah, so this is it. So this is basically that whole app that I showed, except for I think one of the pages was loading from something else. So I've got the login, I'm setting that logo. This is pretty readable. I'm not sure if I understand. Oh, I see. Oh, I see. Thank you. So it's this part is common. So, and the sidebar is common as well. Yeah. Mm-hmm. Any other, yeah, over here.
Hi, thanks so much for your talk. Really interesting. I want to ask you some more about those fragments later.
Yeah.
I'm kind of new to Streamlit and I just fell in love with it. It's just such a great solution. So I'm just a little bit curious about sort of the product roadmap and vision for Streamlit.
Absolutely.
That seems to be happening here. When I came across it, it seemed like a very simple solution to get up prototypes and display data viz and stuff like that. And it seems now, introducing auth and multi-pages and all this complexity, you're almost going in a direction of just like competing with kind of full-on front-end frameworks. Could you speak to that and like what's the vision for Streamlit going forward?
Yeah, that's a great question and a very insightful one. Thank you. So what I would say is that, we think that one of the things that is most magical about Streamlit, and Amanda and Tiago, keep me honest, we think that one of the things that's most magical about Streamlit is exactly what you're talking about, that ability to get started, to iterate really fast. The fact that I could build this app in like an hour and a half or something this afternoon is amazing. And that is something that's extremely important to us that we kind of preserve as part of the Streamlit DNA. And as we talk about adding some of these more complex features and things like that, like making sure that we're not doing anything that that undermines that ability to get started really fast. And so I think something that you would not see us do, for example, is like make some big breaking API change that's like, oh, now I have to make some Streamlit app object and define a bunch of stuff on that or whatever before I start just kind of writing the core interaction. I think we're not interested in doing that. I think what we do also see is that there are a lot of folks who who get started with doing that and then get to a certain point and they're like, oh, I really want to add auth to my app, or I really want to do this dynamic multi-page thing or something like that. And we're basically like, well, there's some plugins that you can use that are kind of a pain, or else like you're going to have to basically decide to switch off of Streamlit or kind of just be stuck with those limitations. And a lot of folks who are trying to get apps to production, to get apps to kind of be productionized, be something that they can share with, a wide internal audience at their big company or, early stage SaaS, and they're, just trying to kind of polish something. So I don't think that we'll ever see Streamlit, or at least, it's not my vision for Streamlit that it would become something that we can say, hey, we're really competing with like a full stack React app that's going to be kind of a consumer grade thing or something like that. Like we're definitely not trying to do that. I think it's more about just like having a bridge to sort of that early stage of productionization, still maintaining sort of the opinionated nature of Streamlit that just makes it really easy to build and get started and not have to think too hard about that, about all these things, but kind of give people that path. And I think, yeah, we hear a lot in the community that that's something that's really desired and that people really want. And the kind of the early iteration part, there's a lot of things that are already really good about it. So I think that's kind of where you'll see some of that focus reflected. But we also are looking at how can we polish and kind of continuously improve and add small things and stuff like that. And Thiago harps on this all the time in a good way, to make sure that, that getting started experience is also getting better regularly. And we want to hear feedback about this too. So yeah, if it seems like we're kind of going too far the other way or anything like that, like please let us know.
We have questions over here. Yeah. Oh. Huh? Oh, yeah, we're gonna do a last question. Yeah? Sorry.
Okay, I was gonna quickly add to that. I'm John, I work at Streamlit. Also like, there's this whole other side, there's the library, but then there's also like the platform, there's community cloud where you can host free apps. And then there's, on Snowflake, you can run Streamlit apps and like everything that like Gabriel presented, for example, like we don't want you to have to do any of that. And so that's kind of one of our goals is that you don't have to figure out like the load balancer situation, how to manage what, like someone's asking on Zoom, how to do the WebSocket. It's like, you just don't have to think of any of that stuff. You build your app, you build your SaaS, whatever you're building, and you just get to like focus on what's core to whatever you're trying to solve. So.
Totally. Thank you, John.
All right, cool. Thank you so much, Joshua.
Thank you. Thanks, everybody.
Cool. How many of y'all are going to go try that out tonight? Oh, I like that. Okay, so our next talk is train you a text embedding model. A behind the scene looks at Snowflake's latest state of the art model release, and that's coming from Luke. A little background on Luke. Luke, oh geez, Slack just bailed on me. Luke is a machine learning practitioner with a diverse background spanning explainable AI, smart manufacturing, financial time series forecasting, and natural language processing. At Snowflake, Luke is a member of the Cortex search quality team that develops text embedding models and other search technologies. So this is going to be really exciting. Got it. You should come up.
Can you see me now? Awesome. Oh, and everyone's eyes get to enjoy my yellow shift here too. Okay. Is there a clicker that goes with this? No, I don't. Oh, perfect. Well, I'll just stand right here. Even easier. All right, excellent. So I'm going to try and make this not super long. I was told 10 minutes, and some of that I just want to be kind of demo QA. So this is going to be the brief look. I will cite if you want to learn more. We've posted a couple blog posts over the last couple of weeks, and also have a tech report forthcoming. So stay tuned. Yeah, I, as well as my collaborators, Danmei, Zhu, Gaurav Nuti, and Daniel Campus have been working behind the scenes on text embedding models for the last couple of months, and we made a release earlier this week of the Arctic embed models, a series of 5 different text embedding models that score very highly on one of the main standard English language text embedding benchmarks. Before I get into all of this, legal disclaimer that Snowflake likes to include in their slide decks. Everything I say here is a lie and don't trust me. And yeah, all of that. I'm going to talk about what a text embedding model is. I'm going to talk about how to train one. I'm going to talk a little bit about how we trained one, and I'm going to show you what it looks like at the end. So text embedding model is basically a function implemented as a neural network trained over a bunch of data that takes in text and gives you something sort of like this schematic here on the left. So you're going to have a concept like Snowflake is a cool or is a cloud native data warehouse. It's also a cool data warehouse. It's also a data cloud, and they don't like me calling it a warehouse anymore. And then you might say analytical databases are typically column oriented rather than row oriented. Those are two concepts, at least in my head, that map close together. And if the model is good, it will project both to vectors in very high dimensional space, not 2-dimensional space like this, which are closer together. And you can then separate geometrically things apart, and then you can use mathematical functions like distance lookup to do things like information retrieval and search. The way this is actually implemented is typically using a bi-encoder architecture, which is shown on the right, in which you take a pre-trained language model like BERT, or folks are trying these with autoregressive language models as well, but still kind of the state of the art is an encoder architecture like BERT, at least when you care about how many parameters you have and actually running this in production. You're going to then run a sentence through it. You're going to get because these are transformers, a sequence of vectors corresponding to the sequence of input words. You're then going to apply some sort of pooling or other aggregation operation to get a single vector. And then you're going to look at a similarity metric between sentence A and sentence B, and then do some sort of loss function in training, which I'm glossing over in this slide. What this gives you is the ability to encode everything to a vector beforehand, store these vectors, U and V, as you see in this picture, in like some fancy database or a not so fancy database or wherever you feel like storing it, and then look up similarity, maybe lower latency setting where you don't have to run these models over all of the data in a real-time way. How do we train one of these bad boys? I don't know if these QR codes are easy to scan from out there, but we have, like I mentioned earlier, 2 blogs about some of the key steps, the tricks that go into the modern kind of state-of-the-art training recipe, as well as the data, which is in a lot of our work what we found to be most important. But the kind of high-level recipe I'll share here is on the left, you're going to have a data set. This is a screenshot of a information retrieval data set that's available on Hugging Face. There are a lot of public ones. If you want to play around with this stuff, it's actually pretty accessible. You don't need 7,000 GPUs to actually get training. These are rather modest. And you'll see that there's pairs here of text, like a question and answer, or the title of a page and the content. And we want to associate the title of one page with its content and disassociate it with the content of other pages. So geometrically, we want the vector coming out of who plays Esther Drummond in Torchwood 2 to be close to the description of that answer and to be far from the vector computed from all of these other ones. And we mathematize this desired property using a contrastive loss function. That's what's shown on the right. So this is some math that I'm going to do that thing that everyone in academics told me not to do, to show an equation and not explain it and gloss over it. But there it is. It makes me feel smart to put that up there. Again, the blogs are probably better if you actually want a step-by-step explanation of what a contrastive loss function is. But we can basically say we go from data on the left, a little mathematics on the right, and then the magic of neural network training to kind of push this desired effect through the mathematical contrastive loss function into the weights of the model. And boom, there we've got one of them. So this is the world's fastest explanation. Again, slower explanations available on the internet at your leisure. And I'm also going to be here afterwards if you want to chat nuanced details. But I think what's more exciting, which is why I saved it for later, is kind of what this work means. And so this is OpenAI released the Ada 2 text embedding model just over a year ago. It quickly became a fan favorite and kind of the one that everyone goes to or went to up until they released a newer version recently. So it's not a state of the art, but for about a year, it was kind of the crowd favorite. And folks spent a lot of time using it. It scored about 50 on this MTEB retrieval benchmark. This is a public massive text embedding benchmark. If you wanted to build a search application, you probably would care about this number. This is a numerical score of how well you search up stuff on these data sets. Our extra small size model now achieves comparable performance on this benchmark. Similarly, you would have had to work with 1,500 dimensional vectors, which take up a fair amount of space, even if you quantize them to like low precision. And now our extra small model is going to give you 384 dimensions, making it 4 times smaller and more lightweight, which will give you 4 times faster lookup, 4 times cheaper RAM costs, et cetera. And instead of getting rate limited to somewhere around 10 to 100, maybe 1,000 if you pay OpenAI a lot of money, documents per second in the cloud, you can actually run 10 to 100 documents per second on your laptop with this model. So this is kind of for, I think especially for maybe the Streamlit crowd here, going from you need an expensive GPU or you need to pay someone who's operating a bunch of expensive GPUs. Now this is open source, Apache 2 licensed. You can download onto your laptop and you can run it even without a GPU at all in a reasonable amount of time. So to show that, I'm going to do some search here. So I went, oh, that's not one. So this is all of the Pokemon. And audience question, how many Pokemon are there? Does anyone have order of magnitude? 800, 5,000 I hear. Do I have 6,000? No, it's not a bid. There are about 1,000 somewhere in there. We'll see. Back when I got into Pokemon, there were like 151 and I like knew all of them. There are a lot more now, but this model is so efficient, we can do all of them. So I've got here, this is probably very small text. Let me see if I can make this big so you guys can see it. I'm gonna run my app. This is going to embed all of the Pokemon live, and then it's going to let you search it. So none of this is pre-computed. This is all on the fly. You can see there are 1,025. Who got that? Bonus points to whoever get that. We're already done, 6 seconds. Now this is cheating a little bit. This is using the shader libraries from the Mac GPU. It accelerates it maybe 5-10 times. So this would take closer to a minute on just the CPU of a regular machine or like a VM, but a minute. It's not that bad. Let's see. I made a mistake. I'm going to need to switch mics and use both my hands here. Can you? Oh, all right. Maybe you can still hear me if I get close. All right. What do you guys want to search? Charizard? It comes up. So this is here. What's interesting about this is the distance between a vector from embedding Charizard, which the model might have seen. We trained it on a lot of data. To this description of Charizard. So it's not even matching the keywords, but it works. Let's do reptilian Pokemon Flametail. Interesting. I Reshiram is not what I was expecting. I think it does have flames and it does use its tail. So this is generation 5. This is past my time, but I think the model's doing okay. Charmander still with a close second, 0.7 similarity. This one evolves. You can see bipedal, reptilian. I cheated. I knew reptilian was in the description, so I picked that word. Maybe I'll do lizard dragon Pokemon Flametail. Let's see. Ooh, Charmander. We like that. Lizard dragon comes up. Charizard is the dragon one though. That's interesting. Oh, he's down here. So this app also, we're looking at like 100 milliseconds of model inference time for this live in a Streamlit app on my laptop. So I would encourage all of you guys out there who want to build search that doesn't need to scale to like billions of queries per second, but just for something like Streamlit to consider these models because they'll run on your CPU. Yes. Sorry? Oh, no. This is there's 1,000 of these. This is using an in-memory array object. I can actually show this is yeah, brute force. I mean, it's 1,000 again, but how many pages are in your documentation? If you want like a documentation search, there are fancy ways of indexing vectors and doing approximate retrieval. But again, brute force retrieval is probably not even, most of this time is going to be running the model for that query if you're using just a CPU. This is very fast. So for example, this embed object is I believe it's just a PyTorch tensor somewhere in here. I have to look at that. Yeah, so there's a tensor object. And if you want to do retrieval, it's quite straightforward. So this is the embed function. This calls the model, and search here. You literally just this is dot product. So for those of you who speak linear algebra and Python code, this is a matrix multiplication operation, a top K function, and re-indexing by the top K, and then you've got your result documents. It's 4 or 5 lines. No fancy vector databases. As much as Snowflake would love you to store your vectors in our databases, you can also do that. So, oh my goodness, yeah, you guys can't see that at all. It's nice and big on my screen. All right, so here you go. This is maybe that's too big and can't see the whole thing.
It's like an actual word in the dictionary.
I would give it to the dictionary. Yeah, so here you are. This is what search is. If you have you're gonna embed the query vector, scores, top K indices, and that's it. 4 lines. That's your vector retrieval. It's not super rocket science. Questions? Yeah.
Really large.
Yeah. No, I can.
For very large data sets, at what point does it make sense to have a connector with LangChain or Llama Index, or do you already have that?
So if you want to perform regular search, like what I'm showing here, where you put in text and then you get back the most highest match to documents by similarity, you want some way of indexing the vectors for what's called approximate nearest neighbors search. And there are a couple different ways of doing that indexing. There's a library that Facebook AI Research, back when it was that, it's called FAISS, FAISS, very popular library, open source. And if your data will still fit in memory, it's a great option for you. If your data doesn't fit in memory, it's a really tricky problem. There's a lot of interesting research there, but we're talking like very big amounts of data at that point, especially if you do indexing, you can fit the index in memory and all of that. So you probably want to reach for something like FAISS or a library that's integrated FAISS or something equivalent. There's pgvector in Postgres. I've heard of ChromaDB. There's like a bajillion. Pinecone's a big hot company that does the indexing. And then platforms like LangChain will utilize retrieval in the background, as well as offer all sorts of orchestration for running generative models and that sort of thing. I'm not familiar with Llama Index. They may also be exactly that. I'm just not familiar. But that's maybe 1 million would be the rough estimate. And it depends on how much this model is 384 dimensions. Our medium-sized model is 768 dimensions. So you might be able to, if you use our smaller model, you could probably go twice as many documents. If you quantize everything to binary, you might lose a little precision, but then be able to go 8 times or 30 times bigger. So it kind of depends on how much RAM you want to pay for. It's a lot of things there, but usually up to about 1 million. If you can still store all that in memory, a couple of gigs of memory, you can, with modern CPUs, do that brute force search in tens of milliseconds per query. So if your query volume is not that high, NumPy might be the vector database of choice for you.
Oh, mine.
Yeah, and you can ask me to search Pokemon things too. I'll give.
I thought for a moment you said you were leveraging Metal, the Mac GPU.
Yes, and I mean the PyTorch makes it really easy. You just set device equal to MPS, and PyTorch has integrated that backend for you. So that's why I'm saying the numbers you saw there. I embedded the Pokemon probably 5 or 10 times faster than I would if I were not using Metal.
Yeah. Is this code going to be available anywhere?
It's not beautiful, but if you want, I've got a QR code here for you. It's a Drive download link. I was still excited to search the Pokemon. I didn't give you guys a chance to scan it. I'm not an expert Streamlit person. You guys are probably not going to want to copy my Streamlit code, but
yeah. Are you going to put it on community cloud? And
oh gosh, so I may be outing myself as a very more Snowflake side person. I haven't used Streamlit that much. I don't really know what the community cloud is, but I think if it ends up on the community cloud, it should be fine. I mean, if you or make it better and then put the better version on the community cloud.
I work on community cloud, so I'm
Okay.
loaded. I'll find you later.
Sorry.
Anyone else? Oh, back here. Oh gosh, what a journey.
Where can we download your model?
A Hugging Face. It's yeah. And let's see. Sorry if you're trying to scan that right now. Snowflake / Arctic embed. If you Google that or your favorite search engine, they're probably using a text embedding model too, and then they'll get you to Hugging Face to download that.
What was the name again? Sorry.
It's if you search Snowflake Arctic embed, but it's this. Oh yeah, this is kind of hard to see. I don't have a QR code for that one. I'm sorry. Arctic. Yeah. Snowflake themed. Yeah. There's also other great models out there. I mean, we're making this open source, and it is, in terms of the benchmark, one of the highest scoring open source models. But there are other ones that are optimized for other things like long context or multilinguality. So one of the great things about this ecosystem is you can play and try a lot of things. But of course, get Snowflake Arctic embed, like I'm here to talk about it. So it's good.
Anything else?
Yes, we have extra small, 20 million parameters, runs all the Pokemon in 6 seconds. Medium is based on a bird base size model, about 100 million parameters, maybe 4 or 5 times slower, twice as big embedding, up to large. We're now talking probably want a GPU for that one, and more than Metal or something like that, but a higher accuracy on the benchmark. But still much, much faster than something like a 7 billion parameter model. These are kind of on the efficiency side more than even like trying to just get the scores. And probably way over time. I can also search Pokemon, in the audience.
Well, I think the important question is, who is your favorite Pokemon?
Who's my favorite Pokemon? Charmeleon.
That was fast.
Yeah, I think it's cooler looking than both the other evolution forms. Not as popular though, being the middle. I was the middle child. I still am. Yeah. This is a casual meetup, right?
I love it.
Everyone's staring at me like I'm. All right. Any other questions that you want in front of the crowd? All right. Cool.
Thank you. So we're going to do some announcements. I have a couple of Streamlit events to talk about, and then, oops, that's okay. And then while I'm setting that up, we're also going to be doing app demos. So if anybody wants to demo a Streamlit app, now's the time. But is anybody looking for a job? Anybody hiring? Now's the time to, yeah.
Oh, hi, I'm Amanda, Streamlit co-founder, also Pokemon fan, partial to Squirtle. Yeah, we are always hiring. You can email hiring@streamlit.io. So always new openings or things coming up. We're specifically looking Bay Area, Bellevue. We also have some kind of related roles to Streamlit that are in Toronto and Warsaw. So engineering, community, data science. We may not have a role open today, but we love hiring from community. Pretty sure that guy came right out of a recommendation. We got a bunch of other people, especially in our data science team and others. And so, yeah, would love to hear from you. I personally get the email, though I'm very bad on email. So we will try to get back to you as quick as we can. But if you are looking, we'd love to hear from you.
Awesome. June 6th, right, there you go. We have a Dev Day, which is a by and for developers during Summit. It's totally free. There's a bunch of AI stuff. You should scan this QR code and register. It's over at Moscone, so nearby. Everybody got it? Okay, I got one more. If you can't make it to Dev Day, check out the forum for all the other Streamlit events that we have, and also just join the forum and hang out because we're cool. So that's that QR code. And yeah, anybody have any apps to demo? I know Luke is, oh yeah, okay. Come on up. Yeah, you. Okay, oh, am I allowed to do that? Yeah. I didn't know, I'm like, it's a Snowflake computer, maybe it has secrets on it.
I was having issues with the Wi-Fi and I couldn't connect.
Bummer, okay.
So my name is Stephen Reagan. I just finished a degree program 2 days ago, so I'm very happy about that. So thank you. I'm going to stephenreagan.com. I recommend everyone else buy their own domain name. I think it's a great thing to do. That's not what I look like anymore, but it's still pretty good. So I have my portfolio here. This is just a project that I built in Streamlit a couple of months ago. And what it is, it's just it's actually on the back of what Luke was doing. We were looking into the archive, ARXIV, for those of you who know about the archive, the preprint submissions and so on. And the archive is just a way of looking at academic papers in different categories, right? And so, we were really, this is part of a much bigger project into academic abstracts. We wanted to understand how language evolves over time within academic communities. But just kind of halfway through this, let's say physics, right? Let's say you're really into physics and you're into the, I don't know, mathematical physics or the astrophysics of galaxies, something like that. And you want to look at what has the archive been talking about over the last 90 days in astrophysics, the astrophysics of galaxies. What have people been putting up on the archive, right? And so I really wish I had the fragments embedded in this because it would have made it just a little bit faster. And I also wish that I had, stopped after finding 1,000 papers. That's a lot of papers. Okay, great. And so just, like I said, I like bokeh, but no one else does. We have a simple, again, we're studying abstracts here for the most part. And so we could just see, a histogram of what the abstracts in astrophysics look like. Everyone likes a word cloud, so there's a word cloud for you. Why not? And then where it gets really fun. So if we just take a look at some of these papers, right? These are in chronological order, right? So we just have, Euclid view. I don't even know what a Euclid view is. I know who Euclid is. I don't know what a Euclid view is of galaxies. And let's say I have these topics here, topic 1, topic 2, topic 3, and you say, well, what defines a topic? And maybe Luke knows a little bit more about this even than I do, but we use something called LDA topic modeling, stands for latent Dirichlet allocation. And the idea here is that we just defined all abstracts into one of 6 topics. And let's see, topic 6 is talking about, active galactic nuclei and redshifts and radio emissions. But if you are interested in, abundance, I don't know what that is, you're looking at topics 1 and 3. So it's just a way of organizing information in the archive. And then the last thing that we added here, the very last thing that we added here, which doesn't always, just quickly, just because it's here, in case you want to understand how to implement something like this on your own machine, there's some code for you, right? StephenReagan.com is, and then the last thing that we have here, if I can just, let's say I'm interested in the Euclid view of dusty star forming. I'm going to copy this link right here. This never works the first time. It usually works the second or the third time, but this is just connected to a Hugging Face model to summarize the article. So it'll probably break the first time. It almost always breaks the first time. I'm still not entirely sure why. I think it has something to do with the Streamlit secrets, but I'm not entirely sure if that's the case because I have to hide the API key somewhere, right? I don't know if that's the reason, but anyway, what it should do is, it's going to grab the paper, it's going to read the paper, and then it's going to batch it into 800 tokens at a time, send it to this Hugging Face model, and just summarize it in really nice conversational tone. So you see this actually broke here because it's going to, see, that's the ugly error that you were talking about, right? The big ugly screen. I can do something different with it next time. And so this is my app. It's for understanding academic abstracts. Like I said, it was part of a much bigger project that we actually finished 2 days ago. Very happy about it. Haven't put that up on my portfolio site yet, but thank you to Streamlit for just having easy widgets that you can play around with and launch things. I guess this is, so see, it's downloading the PDF, right? As it says. And then it's reading and processing the first batch. And usually the first batch is going to be like, here's the abstract of the paper. And so you can see, well, let me zoom in. Well, I can't zoom in, but if you could see in the 1990s survey using the blah, 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 and then it gives you a summation of the next maybe 3 or 4 or 5 paragraphs, whatever 800 tokens is. And it's just going to read through and just summarize the article for you into 12 batches. If it's more than 800 times 12 tokens, then sorry. And then it's just going to summarize all that at the end. Just a nice little conversational hugging face. So yeah, the total luminosity of a galaxy is the sum of stellar luminosity and AGN luminosity, obviously. Duh. That's my app. Thank you for letting me use your computer.
That was awesome. Any other? You got one? Do you need my computer as well? Okay. Isn't that what's so cool about Streamlit? Is that you can share it really easily.
Yeah, it's awesome. All right. My name is Max, and I love fantasy baseball. Any fantasy sports people here? Yeah? A little bit? All right. Well, some of you may get this a little bit in the weeds, but what is it? That's streamlit.app? Yeah. Nice. All right. So this is basically something that I wanted for a long time and doesn't exist for available tooling that I found. So fantasy sports, for those of you who are not familiar, is fantasy baseball in particular is you hold a draft with 10 to 12 of your friends and you pick players in Major League Baseball and they go onto your team. And then the stats of those players accumulate over the season and give you cumulative stats, and you compete with the other teams to see which can have the best stats. Now, there is just two concepts to understanding this. First of all, there's something called a keeper league, which basically means that you can keep players that you drafted the previous year at their draft price. So, for example, let's see, who's a SF giant that had a good year last year? Jorge Soler, free agent acquired by the Giants this year. He had an unexpectedly good year last year, right? So his draft cost last year was a lot cheaper than his draft cost would be this year. So maybe Jorge Soler would be a keeper for you, okay? Now, there's something called average draft position data. You look at like all the drafts going on, like across all leagues on like a certain platform, you get data on like when is a player on average drafted, okay? And this gives you a sense of like, well, I think that, Dalton Varsho is going to have a good year, but on average, he's going in the 16th round, right? So what this is a visualization of if the draft were to happen just by ADP, this is where all the players would get drafted, right? And these are common things, these ADP boards, but what's not common is a way to visualize these things with the keepers removed. So that's what I built. You can adjust your league size, and then you can say remove keepers from the board, and it'll say, these are players, say, being kept. Right, and then it'll recalculate what the ADP board looks like with those keepers removed, okay? And it's not out there, but it's a really useful tool for if you're in a keeper league. So that was probably Greek to a lot of you, but from a Streamlit point of view, some things I wanted to highlight that were cool about this project. I used a fellow named Pablo Fonseca made this really cool framework called Streamlit AgGrid, which provides interop with a JavaScript framework for creating grids like this. That's just like a bit more robust than the primitive grid that comes with Streamlit. And so for example, like the data frame backing this, there's all this calculation about like what ADP position each person should be and where they should be on the board. And when we recalculate the board, that's all, it all changes. So for example, if I want to, I just want to display the name and color coded by position, right? This AgGrid will allow you to just like, for example, select what part of, if I'm storing this data as like a tuple or something in these data frame cells, AdGrid will let me just show the name, for example, do stuff like that. I'd have this draft mode feature where, say I'm in a draft, I could just like select which players have been drafted, right? That's something else you get with this AdGrid stuff, is like selection stuff like that. So if you're looking for more robust grid functionality, I highly recommend the Streamlit AdGrid framework. It's a little wacky, just like putting in like unsafe JavaScript code, but it works. So it's cool. So yeah, there you go.
All right. Well, we had a little bit of everything tonight. Any other? No, y'all all ready to talk to each other? Oh, cool. You want to plug in you want this one or that? No, I have too many things.
My name is Eric Hartford. I'm the author of Dolphin and Samantha models. They're pretty popular.
Okay. There you go.
Hello, is it working? So I've used Streamlit like twice. I was just playing with the new Mixtral Instruct 8x22B model. And I found just randomly that it's really good at Dungeons and Dragons. So I said, well, wouldn't it be cool if I could spin up a little app and with Streamlit and actually, show like a picture and stuff. So I had this thing where I said, let's see, I am Blarg, a level 1 half orc warrior. I am entering a town. Please describe my surroundings. And if this is nice, it's gonna work. But so it'll show the response, and then it's gonna actually generate an image with stable diffusion and show that. So, I guess this is going slow. Oh, in the background, this is Dolphin training, on the 8x22 model. So a little preview. Well, usually it's faster than that. Oh, it's downloading the stable diffusion model. And there it goes. You are Blarg, the half-orc warrior. I want to find an inn so I can drink. Oh, there's the picture. So yeah, it's cool that I could put this thing together. What I like about Streamlit is I could put this thing together. I have very little knowledge of it, but it was so easy, and I just asked my LLM to write the code for me, and I just pasted it in and got it working. So it's pretty cool.
Oh, I see what happened. Okay, there we go. Oh, yeah, one more. Oh my goodness. Did you?
Hello. I'm going to show an app I made a long time ago. I'm Thiago, one of the co-founders of Streamlit. The reason I'm showing this is because some people are looking for jobs, and they think it's a good thing to make your GitHub repo look awesome with this. So let's see if this is working. There it is. So this app is called GitDraw. So if you're tired of having your GitHub repo have this really ugly chart that's really empty and doesn't say anything, what you can do is you go here to Git Draw, the Streamlit app, you draw something. I'm gonna say, hi. Oh, it's really hard to draw in front of a crowd, apparently. And there's a thing people say is that it gets harder to write, to type, the more people are watching. I think drawing is even harder. So let me do this, cool. Now I'm gonna say, use this chart. Make it a little bigger here. Now I can type some other stuff. Give me a sec. So what this is doing, this is on, or not? All right, it's on now. What this is doing is this is gonna kind of hack Git and create a repo by hacking stuff. I forgot how I did this. I copied some code from some security researcher. I was trying to find bugs in GitHub or something. And this is generating a bunch of fake commits. And you download a zip. Now what you're gonna do is you get your zip file, you create a repo first where it's gonna go. I'm lazy, I'm gonna click what it says here. I'm gonna give it a name, Git Drawing. I just tried it out to see if it's working, and it is, so there it is. Cool, I have a repo. So now, cool, I'll go download the zip, so unzip, downloads, Git Drawing, great, CD Git Drawing. Now I just got to connect this to my repo. So copy this thing. Oh, my name needs to be replaced here. My repo is under my username there. Oh, already exists. Apparently I already did this. Let me see here. Do this again. All right. Now I can do this. Oh, I'm in the wrong place. Aha. Somebody said this out loud and I didn't even. Now push. And let's see if it worked. Now I'll go here and reload. Oh, not the wrong place. Reload. Hi. There it is. So write a message to your recruiter this way. Thanks.
All right, that was awesome. Cool. I think that's it. Let's have another round of applause for our speakers and our app demos and all of that. Yeah, is there anything else? Cool. Go network.